Yo, what is up? I am sure you are going to be super sad to hear this, but this is the last lesson that I'm going to teach you this year. I know, super sad, right? Like, totes sad. And as sad as it is, we still have to go and learn something, so we're going to go ahead and talk about Chapter 12, Lesson 5, about scatter plots. Now, I like this lesson. I think this is really easy. More importantly, this is really important because we're going to be looking at data. I know, super important. But the whole point of this is to figure out, like, what does it all mean? Why do we even do this? All right. So by definition, a scatter plot is a graph that shows the relationship between two sets of data. And to make a scatter plot, all we're going to do is graph the data as ordered pairs. Now, before we do that, example 2 is going to talk about how to graph data as an ordered pair. We're going to go ahead and look at an example of a problem that we would look for. And why do we even do this? Why is this so important? All right. So the scatter plot shows education and income data. How many years of education does the person who earned $100,000 have? Now, this is a really important question, not just for math, but for life. Because the truth is, life is not fair. You've heard me say that before. And just because, like you would think, if I asked you, okay, just in general, a person who has more education, does he make more money or less money? Most of the time, the more education a person has, the more money they have. Like example, a doctor. A doctor would go to elementary school, then middle school or junior high, high school, college. He'd have to go to a medical school, and he'd have to be there for a very long time. But the more time he spends at school, the more money a doctor would make, because doctors tend to make a lot of money. But that's not always true. Just because you spend more time in education doesn't mean you're going to make like $1 million. It doesn't work that way. Because I spent quite a bit of time in education, but it doesn't mean that I'm going to make a lot of money because I have a different job. I am not a doctor, as you guys know. So, in life, very rarely, like if I've given data, do we have straight lines. Most of the time they kind of do this. The data is kind of scattered because some people might make a little bit of money and some people might make more, but there might be some people that make more money but work for less time or go to school for less time. Like this example right here. This point right here, this person went to school for less time than this person. This person made less money. Now, how do I know that? Well, it's very important that we're able to look at the important parts of this scatter plot. So first thing I want to tell you that every good graph has to have the axes labeled. We have to know what these mean. Down here, these numbers 8, 10, 12, 14, 16, these represent the years of education completed. How do I know that? Because they labeled it. These dots would mean nothing unless they told us what these axes mean. So the x-axis talks about the years of education, and we're going to compare that to the y-axis, which tells you how much money they make in thousands of dollars. So they even notify that this is in thousands of dollars, meaning this person didn't make $10 a year, they made $10,000. This person up here would have made $70,000 because it's 70 times 1,000. Okay? So what we're going to do is we're going to look for the crossing point between these two axes, and we want to figure out how many years of education does the person who earns $100,000 have. So we're going to try to find $100,000 on the income. Here it is. And we're going to go over to the right until we get to a dot here. Now, this person right here, whatever data this is, they say that they made $100,000 that year. How many years of education did they complete? Well, if you go right to the dot and you go down to the x-axis, you're going to figure out that this person went to school for 16 years. Does that make sense? Kind of? All right. Let's go ahead and try another one. Let's try point. All right. All right, $90,000. $90,000. So 90,000's over here. All right, now the person that would make $90,000 is this guy right here, point B. If we go down, how many years of education did they complete? 14. Now it can work the other way around too. We can go ahead and ask, well, how much money did a person who go to school for 10 years make per year? Well, 10 years, you can go up and then over about $30,000. Now, it's not a guarantee that every person that makes this is just this certain job. So let's go ahead and describe the person represented by point A. Point A is down here. How much money did they make per year, annual income, and then how much education did they have? Well, this person made $20,000 per 1 year and had 12 years of education. So we're assuming they graduated high school. Okay. Does that make sense? So a lot of your questions on your homework are going to deal with being able to interpret this graph. And that's really important. Being able, like, there would be no point to have graphs in general unless we were able to interpret it. Okay. Now we're going to go ahead and use a table to make a scatter plot of latitude and temperature data. Now this is important. All right. Whenever they give you information, they ask you to make a scatter plot. They're actually giving you the order in the way that they read the question. They want to make a scatter plot for latitude and temperature data. So latitude is going to be the x-axis and temperature data is going to be the y. How do I know that? Well, because I tell you this all the time, that we read English from left to right, we do math from left to right, and we read graphs from left to right. Now this table that they're giving us for climate data gives us a lot of different information. They give us the cities, they give us location for latitude, they give you the mean temperature and precipitation. Now for this question, they're asking for latitude and temperature. So that means we need these values and these values, latitude and temperature. And these two values are going to make an ordered pair. So if I graph this, I would go ahead and put this as my x and this is my y. How do I know this is the x? Because we have to read it in order. Latitude is the x, temperature is the y. If they switch the order, it would be the opposite. They would be telling us to put the first one in the x and the second one in the y. So if graphed all of this information, we're just going to go ahead and make an ordered pair. If I make a graph, all right, I figure out that 34 and 61, x and y, is going to be right there. Now notice a couple of things. Notice these graphs, they have this little squiggly mark, these little squiggly marks. And what these squiggly marks mean is they're breaks in the graph, and they're saying, well, the data ahead of it doesn't really matter. We're only concerned from this point. So notice the squiggly mark starts, and instead of counting each box by 5, 10, 1, or 20, they said here we have 20, and then after that we go 2 boxes is 30, 2 boxes is 40. So they're saying that every box is worth 5 down here. Okay? But notice they have the squiggly mark. So this means a break. That means that there are numbers that could be before it, but we're not going to count them. We're going to start counting from here. These data spaces have to be equally spaced. Every box is worth 5. All right? And you don't have to necessarily have the same spacing or the same scale for the y values as you do the x values. Here, they're counting by 5 again. So easy, it could have worked out. All they did was take these values and then they plot them in a graph. Now, if you wanted to, you guys can use Microsoft Excel, or if you guys go to Google Drive, let's Google Drive, and then you make a new Google Sheet, Google Sheet. So we can go ahead and use Google Sheets, and we can actually make the same thing. Instead of having to graph this, I'm going to show this to you guys. I'm just going to type in latitude and then temperature. All right, then I can input the data from the table. I'm looking at the book, 34, 42, 42, 47, 21, 30. I know this is exciting watching me input numbers. All right, 33, 44. I only have 15 minutes to record this. I'm taking my time. Why don't I just stop it and just, input the numbers and then record? That would be much smarter and a better use of our time, but I guess I'm just going to talk through it. Input these numbers. It's so exciting to do this. 45, 64, 56. All right. I inputted all the numbers for latitude and temperature. What I'm going to do is I'm going to highlight these. All right. And I just made my table. And if I go to Insert Chart, it's going to actually take all this data, and it made a scatter chart for me. It recognized that this is a scatter chart, and this is something that we can utilize. All right. So isn't that exciting? All right. You can change this into a scatter plot, or I guess it's the same thing. All right. And it took all that information for us. Notice it took the X and the Y. It actually labeled our axes. All right. Good for us. All right. Cool. All right, so I highly recommend that you use Google Sheets and kind of get used to it, because that's going to be a very valuable skill using any Excel-based program like that for graphing. Very important, very easy. All right, last thing we need to talk about, kind of easy, are the differences between positive, negative, and no correlation. The word correlation comes from the root word co, which means with, and relation, which has to do with multiple points, or just the relationship between different things. So what we want to figure out, is there a general pattern for all of these little scatter plots? We call it a positive correlation if the general direction is going uphill. Like a positive slope going uphill, we call it a positive correlation. For this one, if we have a general trend where they're going downwards, we call it a negative correlation. And if they're all kind of scattered and we can't really tell if it's going up or down or left or right or what's happening, we call it no correlation. So let's go ahead and look at example number 3. Use the scatter plot below, and they're asking, is this positive, negative, or no correlation? Well, looking at these dots, it seems like the general trend that as X increases, Y is decreasing. It looks like it's going downwards. All right, so we can say that this is a negative correlation. Notice it's not a perfect line, and with scatter plots they probably shouldn't be perfect lines. They should not be perfectly straight, but we get a general trend that as time goes on, all right, that these winning times for the 110-meter hurdles are generally going to be going lower. There's less time, means they're running a faster race, which makes sense, right? Because people should get more athletic as time goes on. All right, as the years progress, nutrition got better, training regimens got better, people got faster, people got stronger, and these times went down. And that does make sense. So this would be a negative correlation. On your homework, you're going to be comparing those things. All right, looking at this, is this positive, negative, or no correlation? Well, it looks like generally these dots are getting a little bit higher, going upwards. So I would say that this has some sort of correlation, and this is probably a positive correlation, because generally these are going uphill. Cool. I believe that is it. All right, you know what? It's been real, guys. I am very proud of you. I had no idea what pre-algebra was going to be like this year, going back to junior high, but you guys made it super memorable for me, and I'm very blessed to have you guys as students. I want to say from the bottom of my heart that I love you guys and care for you guys, and if you ever have math questions, I am here for you. I want to do my best to help you guys out, and not only this year but next year. You guys are true blessings, and if there's anything that I can get through to you guys, it's one, that math is fair, but two, right Miriam, hashtag math is fair, but two, you guys are so amazing, and you guys have so much good that you guys can do. I just want to encourage you guys. Treat each other right. Treat each other the way that you're supposed to, the way that God wants you to. All right. Love you guys. It's been real. That's all I have for you this year. We will review. We will get you ready for your final. But other than that, this is your last math lesson from me. Don't get got. All right. Be yourselves. Math is fair. See ya. Peace.